Hi, my name is Jessica Kwan-Ohashi, and today I'm going to review extracellular vesicles derived from oxidatively stressed stromal cells for cancer work. Why should I be part of science research? I have scientific skills such as researching, identifying biases, um, uh, uh, developing questions, hypotheses, methodologies, identifying variables. I am comfortable with math, which is good for scientific literacy. And I collaborate with others, which is good for developing strong relationships and finding a mentor. And I have life skills. I'm punctual and organized and time managed. I have good time. I have time management, and I have problem solving. I am passionate about science, past experience about my passion, and I love how science explains the world around us in a logical and evidence-backed way, and I want to inspire other girls to pursue STEM-related careers in the future. Why I chose this article, I am interested in the human body and especially cancer and what happens at the cellular level, and I'm also interested in how stressors such as affect cancer progression, like both environmental and psychological. And chemotherapy is like it has a lot of downsides, so I kind of want to like learn about it and see if like there are other therapeutics that could like replace it. Cancer is a very big topic in the world, and we have it's increasing. So this article had a lot. So this article aims to study the tumor microenvironment increases risk of developing oxidatively stressed stromal cells. Oh, sorry. Tumor microenvironment increases risk of developing cancer. And so basically, oxidative stress stromal cells um, send extracellular vesicles to tumor cells, and that can cause cancer progression. Cells were treated with hydrogen peroxide. This is a very common molecule used to induce oxidative stress in cells. EVs were extracellular vesicles were extracted and put into cancer cell lines, and the results were recorded. Today, many of us face challenges of lack of access to food, obesity, smoking addiction. We have a lot of pollution, unfortunately, nowadays, and anxiety and depression are really big, and these factors can actually cause oxidative stress in us, which can increase our risk, which like may increase our risk of cancer progression. That's like and what the studies about. Okay, oxidative stress causes like again environmental stressors, radiation, lack of access to food, um, and anxiety. Chemotherapeutics actually are a stressor of oxidative stress, but they actually kill tumors instead of promote um, cancer progression, like lifestyle and environmental stressors. Um, Obviously, metastasis travel can from the primary um, spot, and it is unfortunately caused to cancer-related deaths. Apoptosis is programmed cell death, which is good, and killing tumors. And epithelial to mesenchymal transition is a transition to mesenchymal type cells, and cancer progression. Okay, so this is there's a lot of previous research on this. A few of them are here. It's just been observed that cancer patients with high stress have worse prognoses. Different stromal cells such as adipocytes and lung fibroblasts act as regulators of cancer progression. Um, Cancer therapy such as chemotherapy use oxidative stress, but chemotherapy has many downsides. In cancer, EVs cause cancer progressions because of the stromal cells, oxidative stress stromal cells they came from. The hypothesis is the TME mediates cancer response to oxidative stress by delivering EVs to cancer cells. What this means is that stromal cells become oxidative stressed, they send their extracellular vesicles to tumors, and basically that they affect the tumors just like that. Basically, the adipocytes and lung fibroblasts were treated in vitro, intraserum-free medium. Oh, wait, and they're treated with 50 milliliters of hydrogen peroxide, and then they're changed to a serum-free medium to grow, and then conditioned medium to for studying, and decreased lipid droplets in adipocytes and lung fibroblasts were activated. Basically, this is the same methodology, except for it was put into an ultracentrifuge to separate the extracellular vesicles. It was put into a nanosite instrument to count the extracellular vesicles, but there was no difference. So, um, there was cell proliferation in some tumors, except for the MDA NB436 one. Western blotting was performed because obviously they saw that there was no change in extracellular vesicles, regardless of hydrogen peroxide. So they wanted to see if the components were actually what affected the tumors. And so mTOR signaling was checked basically to signify cell proliferation and increased phosphorylation of like level in some cells, except for MDA MD436 or and yeah. Um, and it was increased in S6 and S6K, which signifies an increase in cancer risk. Um, Changes in EMT were investigated. They just saw more mesenchymal markers in the cells. You can see that there's less lipid droplets here. They're more disorganized here, and the hydrogen peroxide side is thicker in SMA because SMA signifies cancer progression. And also the oilo red staining is why it's like that. You can see here it's just telling us that the extracellular vesicles there wasn't really a change. Um, Hydrogen peroxide, the extracellular vesicles, there was all more cell proliferation except for an MTA MD46, is the same thing. And then in C, we can see that S6 and S6 were increased, which basically just shows cancer progression. You can see in A549 and PC9, there was no change in cell proliferation. These are kind of telling us the same thing. And then basically fibronectin, vimentin, PAI1, and benzoin is increasing mesenchymal, which is why they're getting thicker. And E-cadherin is a decrease in epithelial, which is basically a sign of epithelial mesenchymal transition. And that's why it's getting thinner, and everything else is getting thicker. This is basically the result in telling us if they progress cancer or not, and this is just the same thing. Discussion, study approach supported current research. But there's also research that went against this too. But finding theory is this is oxidative stress is implicated in many diseases. This is really important because this can affect other studies, and because oxidative stress is basically just destroying cells like neurons and blood cells. Like it's really implicated in many other diseases. Um, yeah. Okay, so there are limitations. Obviously, mice are different from humans. Hydrogen peroxide is one of the oxidative stress used to induce oxidative stress, but there are many forms of oxidative stress, and all of them come with different effects. So if you use another form of oxidative stress, it could have had a different outcome. Research was done in vitro. Obviously, it could have been done. It would have been different if it was in vivo because organisms are very complex things. Like complex. The observations were made after only 4 days of treatment, which is pretty short, so it could have been different if it was long term. And there was clear research question, results were interpreted clearly, like which I really loved. The hypothesis was supported, and regulating the tumor microenvironment might increase risk of cancer. Oxidative stress may increase risk of cancer proliferation and metastasis. Those basically the main ideas. I want to thank all my teachers. They always inspire me every single day, and my mom. And thank you so much for listening to our research presentation. And